In the diagram below, A and B are the x-intercepts of the parabola with this equation. So we know that these two particular points here, these are the x-intercepts of the parabola. A straight line G, right, through A cuts the parabola at C and the y-axis at this point. So we have a straight line, okay, so that passes through A. So this straight line cuts the parabola at this particular point here, and it also cuts the y-axis at this point here, right, with the coordinates 0 and 1. So they're also telling us that now M is a point on F on the parabola. So this particular point here is a point on the parabola, and N is a point on the straight line graph. So we have N as well, which is a point on the straight line graph, such that MN is parallel to the y-axis. So they are further telling us that now this vertical line is parallel to the y-axis. MN cuts the x-axis at point T. So they're also telling us that now this point, which is point T, it's the point where this vertical line cuts the x-axis, right? Now for 2 marks, they're asking us to show that the equation of the straight line is x plus 1, g of x equals to x plus 1. Okay, so that's 6.1. So 6 point. We know that the equation of a straight line is y, which is equals to mx plus c. Okay, so what we're going to do in this particular problem, we're going to substitute the coordinates of c, which is 4 and 5. So we see that y is 5, which is equals to m, x is 4 plus c. Now if we look at this c, we know that this straight line passes through this point with these coordinates, right? So we can substitute the value of c as 1, because we know that c is the y-intercept. So we have 5, which is equals to m into 4 plus the 1, right? So if we try to solve for y, or rather for m, for the gradient, we can take this negative 1 over to the other side. So we're going to have 5 minus 1, which is m into 4. So we have 4, which is equals to m into 4. Dividing both sides by 4, the gradient is 1. Now we can take this gradient and substitute it in this particular equation. So we will have y, which is equals to gradient, which is 1x, plus the value of c, in this case, which is 1. Therefore, indeed, we can see that the g of x, the equation of g of x, is x plus 1. So this is what we were asked to show in this particular question for 2 marks. Now they're asking us to calculate the coordinates of a and b. So this is 6.2. So we know that we have f of x, which is equals to x squared minus 2x minus 3. They're asking us to calculate the coordinates of a and b, and we know that a and b, those are the x-intercepts. For x-intercepts, you let y to be a 0. So we'll have x squared minus 2x minus 3. So if we try to factorize these, we're going to have x and x, okay, which is equals to 0. Factors of 3, it's 3 and 1. So this is going to be a negative, and of course this is going to be a positive. We can see that product of the inner terms to that, if you add the product of the outer terms, you are indeed getting the middle term. So our factorization is correct. So x is negative 1, or x is positive 3. Therefore, the value of a is negative 1 and 0, and the coordinates of b is 3 and 0. Now 6.3, they are looking for the range of the parabola. So we know that to find the x coordinate of the turning point, remember, if we're looking for the range, we have to find the y coordinate of the turning point. We know for the x coordinate of a turning point, we can use negative b over 2a. We know that the value of a, it's this one, the value of b is this one, right? So this is going to give us negative into negative 2 over 2. The value of a is 1. So this is the x coordinate of the turning point. So the x coordinate of the turning point in this case, it's positive 1. So we're going to say f of 1. So wherever we see x, we're going to substitute 1 in this particular equation. So we're going to have 1 squared minus 2 into 1 minus 3. And of course, this gives us an answer of negative 4. So f of 1 is negative 4. Therefore, the range in this case, it's any y value that is greater than or equal to negative 4. Remember, the coordinates here is 1 and negative 4. And of course, the range is any y value that is greater than or equal to the negative 4. Now 6.4, what they're saying is that if mn is equals to 6, so if they gave you the value of mn as 6, determine the length of OT if t lies on the negative x-axis, we have to then show all our workings. So they're telling us that, remember, this line was parallel to the y-axis, so that's the information that we know. So they're telling us that now if this line is 6 units, okay, so if this line is 6 units, this length of mn, if that is 6 units, what is the length of this ot? So they're looking for the length of ot. So the first thing that you have to then do here, you have to know the coordinates of m and n in terms of x. So we know that if the x coordinate here is x, the x coordinate of m. So if this is x, the y coordinate in this case, you have to substitute x wherever you see x. So it's going to be x squared minus 2x minus 3. Remember, if you have the x coordinate as x and you're looking for the y coordinate, you just take this value and you substitute on the equation. So if you take this value and substitute on the equation, this is what you get as your y coordinate. But remember, this is a vertical line. It means that now if this is x, then this is also going to be x. And of course, remember, if you have the x coordinate and you're looking for the y coordinate, you just take this x coordinate and you substitute into the equation of the straight line. Remember the equation of the straight line in the previous video, this was x plus 1 in the previous question, right? So wherever we see x, we're going to substitute into that equation, and of course we're going to get x plus what? Plus 1. So what I just did here, essentially, I just found the coordinates of m and n in terms of x. So that's the first thing that you have to then do to solve this question, right? Now we know that if we're looking for the length of a vertical line, right? So we know that if we're looking for the length of a vertical line, in this case, if we're looking for the length of mn, we're going to say, well, the y coordinate at the top, which is the y coordinate at m, minus the y coordinate at n. So this is how you then find the length of the vertical line. If you have a vertical line, you say y top minus y bottom. Okay, so we know that mn is equals to, what is the y coordinate at m? That's going to be x squared minus 2x minus 3. So that's going to be x squared minus 2x minus 3. And of course, what is the y coordinate at n? That's going to be x plus 1. Okay, so this is what we then have, right? But remember, we know the value of mn. So we were given the value of mn as what? As 6. So we're going to substitute that as well. So we're going to say, well, this is going to be 6, okay, which is equals to this, whatever that we're looking at, right? So we know that we can simplify this. We have x squared minus 2x minus 3 minus x minus 1. And of course, on this side, we have a 6, right? So we can add the like terms. We have x squared minus 3x. If you add these two, it's minus 3x, negative 4x. And if you take this 6 over to the other side, it's going to be negative 10, which is indeed a 0. Right, now it's a matter of then factorizing these. So we know that this is going to be x, and this is also going to be x, which is equals to 0. Factors of 10, so that's going to be 5 and 2. So that's going to be 5 and what? And 2. So this is going to be a negative, and of course this is going to be a positive. We can see product of the inner terms, it's negative 5x. To that, if you add the product of the outer terms, which is 2x, negative 5x plus 2x, you are getting the middle term. So the factorization is correct. So our 2x values is 5, or the x value of negative 2. Right, but remember, we are only concerned on this negative side, negative part. So this one, it's going to be not applicable. You're going to consider this answer. So in this case, we know that the x coordinate here, it's going to be negative 2. We know that the coordinates of t, it's negative 2 and what? And 0. Therefore, the length of OT in this case, it's going to be 2 units. Now 6.4.2, they're saying hence you must then write down the coordinates of n. We know that we have the graph g of x, which is the straight line, which is x plus 1. And of course, remember, we know that the x coordinate at this point, remember I said it's negative 2. So the x coordinate at t, it's negative 2. So it's going to be the same as the x coordinate at n, which is what? Which is negative 2. Okay, so it means that now if x is negative 2 and if you're looking for the y coordinate, you just have to substitute that. So we're going to say, well, this is g of negative 2, which is equals to negative 2 plus 1. So g of negative 2 in this case, it's going to be the negative 1. So this is going to be negative 1. Therefore, the coordinates in this case of n are going to be negative 2 and negative 1. So these are the coordinates of what? Of n. 6.5, essentially what we have, they're saying we must determine the equation of a tangent to the parabola that is parallel to this line. Remember, what is the equation of this line? It's g of x, which is equals to x plus 1. So we're saying that now we have a tangent which is parallel to this line. So we must determine the equation of this tangent. Remember, this is the tangent to the what? To the parabola. Right. So the first thing that you want to do you want to take this parabola and you want to differentiate that. So if you derive that parabola, what we're going to have f prime of x, which is equals to, remember, you take 2, you multiply it with the coefficient 2, you subtract 1. So that's going to be 2x, right, minus the 2. Okay, so this is the derivative. So this is the gradient. Remember, a derivative, it's a gradient. So it's a gradient at a point. Okay, so this is the derivative. So it's a gradient of this parabola at any point. But we know for a fact that this tangent line has a gradient of 1 because it's parallel to what? It's parallel to this straight line. So we know that the gradient of these tangents that we're looking for is 1. So we're going to take this derivative, okay, which is a gradient at a point. We're going to equate it with that gradient of 1. And we're going to try, when we equate that, we're going to try and solve for this point. So essentially, we're looking for this point, okay? So we're going to say, well, we know that we have 2x minus 2. We're going to equate this with the gradient of what? With the gradient of 1. So this gradient of 1 is the gradient of this tangent line. So essentially that we have these now, we're going to then try and solve for the point of tangency. We're going to try and solve for this point. So we're going to have 2x, which is equals to 3. Okay. Therefore, the value of x in this case is going to be 3 over 2. So this is the x value at this point. So we're going to take this 3 over 2 and we're going to substitute it onto the parabola. Remember, we don't have enough information on the tangent line. That's what we're looking for. We're looking for the equation of the tangent line. So we're going to substitute this into the what? Into the parabola. So we're going to say, well, we know that f of 3 over 2, wherever I see x, if I substitute 3 over 2, I am indeed getting an answer of negative 15 over 4. Okay, so this is the answer that I'm going to get. So we know that that point of tangency, it's going to be 3 over 2 and negative 15 over 4. So it's this particular point, negative 15 over 4. Now that we have this and we have the gradient of this tangent line, we can then now solve for c. Remember, the equation of a straight line is y, which is equals to mx plus what? Plus c. But remember, what we can then do is we can substitute these points. We know y is negative 15 over 4. So the y value is going to be negative 15 over 4, which is equals to, we know the gradient is 1. Okay, we know the value of x, it's 3 over 2. So that's going to be 3 over 2. So it's y, which is equals to mx plus c. Rather, if we subtract 3 over 2 from negative 15 over 4, the value of c in this case, we see that this is equals to negative 21 over 4. So this is the value of c. So the equation of a straight line of a tangent to the parabola, it's going to be y, which is equals to mx, right, minus 21 over 4. So this is the equation of a what? Of a tangent line. So we know that this tangent line has a y-intercept at negative 21 over 4. So that's the tangent line. So 6.5, they're saying for which values of k? Remember what is k? K is this value over here. So it's essentially the y-intercept. So they're saying for which values of k will this parabola and this equation, this straight line, not intersect? So we know that when this y-intercept is negative 21 over 4, it intersects once, right? But if k is greater than 21 over 4, so if k is greater than 21 over 4, that tangent line, that tangent line is going to shift up because k is greater than what? Negative 21 over 4. Essentially, we're going to intersect twice. Remember, they're looking for the values of k, the values of the y-intercept where these two lines, or where these two graphs are not going to intersect. So essentially, your answer for 6.6, you're going to say, well, those will be the values of k that are less than what? That are less than negative 21 over 4. Okay, so negative 21 over 4. Because if k is 21 over 4, we know that the equation that we're going to have is this. If k is what? Is negative 21 over 4. So this is the equation that we're going to have, and it's a tangent line. So if k is a value that is greater than this, we're going to intersect twice. But if k is less than this y-intercept, it means that now this tangent line is going to shift down, meaning that now we're not going to do what? We're not going to intersect the parabola. So the value of k in this case, it's negative, or rather k is less than negative 21 over what? Over 4.